Welcome to my new calculus channel. My name is John Gabriel. In this video I'm going to talk about a debate I had with Anders Kaesorg from MIT regarding the definition of Cauchy's derivative. So I'm pretty sure that most of you know how Cauchy's derivative looks. So what you normally see in most calculus textbooks is something like this. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all divided by h. Now this definition is flawed for several reasons, but in this video I'd just like to show you that it's actually circular, and I tried to show this to Anders Kaesorg during our debate. If you go back to this original document, he says let's differentiate the function x squared using the formal definition of the derivative. So if we translate that formal definition, well, first of all let's remember that in order to do that we need to know how the limit definition is defined. So this is how it's defined normally. We have the distance between x and the limit point c is less than delta, and this is true whenever, actually we don't even have to, they don't normally have that implication there, so I'll take it out, but it should be there in my opinion, but it's not normally there. We normally have an implication that f of x minus L is less than epsilon, right? So Kaesorg uses this definition in which he shows how the derivative definition is to be interpreted. So if you look at the document again, which is right over here, it says using the formal definition of derivative. So it says for any epsilon greater than 0 we pick delta is equal to E, and for any h not equal to 0 with h less than delta we have this particular inequality here. So what he's doing is he's saying take the finite difference, which is that there. Yes, the finite difference is this. So let's go to this other paintbrush here which I have, and I'll show you exactly what's happening in a moment. Now, in order for this definition here to be true, this definition, okay, we need to have a hole at x equals to c. Okay, so we need a hole in the function. And why do we need a hole? Because this inequality says the distance between x and c must be greater than 0. And also we need to know the value of L. So now wait a minute. The value of L happens to be the derivative. And you'll see how that actually it turns out to be completely circular. It's not even an actual definition. I'd rather call it a verifinition. So I'd rather call it a verifinition because it doesn't define anything, but it's used to verify that your choice of L is true, okay, or that the L that you think is the limit for this particular C is indeed the correct L. So to summarize, it is used to show that L is the limit. But it is circular because L is required to be known. And how so? Well, if you look at the definition on this page here, what you need is f dash of c to be equal to the limit as h approaches 0 of f of c plus h minus f of c all over h, okay? And so what you have in here is this expression which is the finite difference, okay? So you're taking finite differences, and guess what? You're comparing them with L. But what is 2x? 2x is in fact the derivative, okay? So where did he come up with 2x? And so I confronted him about that. Yes, let me show you how I confronted him about that. So he gave a little spiel there about a whole lot of nonsense, and I said to him, well, how did you get 2x? You would have had to differentiate first. Not even close. So he begins off again by saying, rigorous formulation of calculus only needs to tell me how to formally justify everything I assert. It doesn't need to say anything about how my brain comes up with those assertions before they're proven. Completely irrelevant anyway. But if you're curious how I come up with 2x, here's how. I want to show that that is arbitrarily close to some unknown value m as h gets arbitrarily small. So he says, we can simplify this expression here to 2x plus h. Oh, really? But we can't do that if h is not equal to 0, right? So that already is illegal arithmetic. It's not possible to do that. But he doesn't care about that, because as far as he's concerned, he reckons that we can use that as a guide to what is the derivative, and then just go ahead and prove that it is in actual fact the derivative by using this definition here. In other words, the one that I showed you on this page. This is the definition, right? So just go ahead and show that that is a derivative using the definition. So it's very circular, because L, first of all, is required to be known. And L is actually the derivative. Okay, so you need to know the derivative in order to prove that it is the derivative. How stupid can you get? Modern academics are the biggest morons. I am so tired of dealing with these fools. I mean, anyone who says that Cauchy's derivative is not flawed is an absolute imbecile. This definition here is absolute garbage. Cauchy was an idiot. I, John Gabriel, say that Cauchy was an idiot. And anyone who follows Cauchy's ideas is an idiot. And that will never change, because what Cauchy came up with is a whole load of rubbish. Well, very well. So what you've seen here is really a definition. So you have in the definition, in this definition here, and we could write it out formally like this. We could say 0 is less than x minus c is less than delta implies that fd minus L is less than epsilon, where fd is equal to f of x plus h, it's the finite difference, minus f of x divided by h, right? But in order to do this at all, to simplify this at all, h must not be 0. But that's where we get the idea of the derivative, isn't it? And of course, L is equal to the derivative at c, since L is part of the definition. See, L is part of the fucking definitions, you morons, you absolute imbeciles. How long will it take you to get this? Oh my word. Well, there you have it. If you don't get it now, you'll never get it. What can I say? Well, I'm really absolutely astounded that for so long this hogwash has been sold and just really stuffed down the throats of naive students who really don't know any better. But you lecturers ought to be so ashamed of yourselves. You teachers should really be kicked out of your classrooms and not allowed to step back into a classroom because you teach such rubbish. A person who really loves the truth and who wants to defend the truth and stand up for knowledge that is well formed and ideas that are well formed isn't a spineless creature like most of you are. You need to stand up and talk about this and reject ill-formed knowledge. Now is the time. Don't wait any longer. As for students, you need to open your mouths and go to your teachers and lecturers and show them these things and tell them that they're idiots for teaching you the wrong things. It's time now to change all this nonsense. Don't wait any longer, because they are piling heavy burdens on you and expecting you to learn a whole load of crap which you don't need to know. In the new calculus, there are no limits. There is no use of infinity, infinitesimals, or the limit concept. The new calculus is the first and only rigorous formulation of calculus in human history. I say human history because aliens may have discovered it a long time ago. Now, I encourage you to go to my site and read up on this, and I'll provide a link to the debate between Anders Kaesorg and myself. Please read the details section of this video before you watch it. I will upload all the information you need to know there. I'd also like to tell you about a new limit method that I came up with, which actually deals with any type of limit. Limits at infinity, limits at a point, and you don't need to have 5 or 6 different definitions as mainstream morons have. Only one definition, and it's geometric. You'll have to download the applet and run it to see how it works. You can type in any function and it works exactly the same for any function that you type in the input bar. It's a GeoGebra applet only because GeoGebra is free. I obviously prefer to use MATLAB, but very few people have access to MATLAB, and those who do don't really know how to use it that well, since it isn't easy to use. So I also have invented another method for verifying, if you really want to go down the idiotic way of the mainstream where you need to verify these through epsilon delta proofs. I've invented a completely new method where you don't use inequalities at all. It's called the inverse function method. And I'll also post a link to that in the details section of this video. Very well, I have a bit of a cold, so I've been struggling to talk, but I hope you've enjoyed this video and that you'll join me again next time for another interesting presentation. This is the New Calculus channel, and I am John Gabriel. Till next time, goodbye.